how Rome without modern machines. Think about building a modern stadium. It's a colossal job, needing fleets of steel cranes, high-tech machinery, and digital precision. But what if I told you that nearly 2,000 years ago, the Romans built an arena just as grand as a Colosseum without any of that? So, how did they pull it off? How did they erect this massive structure of stone and concrete, standing as tall as a 13-story building and holding somewhere between 50,000 and 80,000 people? The answer isn't just brute force. It's a masterclass in brilliant engineering, clever politics, and a few secret ingredients, the political blueprint to understand how the Colosseum was built. You first have to ask why. The story doesn't start with an architect's drawings, but with a political game plan, born from the chaos of civil war. In 68 AD, the despised Emperor Nero was gone, leaving Rome in turmoil. What followed was the bloody year of the four emperors. As generals battled for control, the man who came out on top was a tough, no-nonsense general named Vespasian. He started the Flavian dynasty and had a huge job ahead of him: unite a fractured Rome and earn back the people's trust. His predecessor, Nero, had built a ridiculously lavish palace in the city's heart called the Domus Aurea, or Golden House. At its center was a giant, man-made like a symbol of one man's indulgence, while many Romans struggled. This is where Vespasian made his genius move. He ordered the lake to be drained and declared that on that very spot, he would build a massive public amphitheater for the people of Rome. The message was powerful. Where Nero had taken land for himself, Vespasian was giving it back, along with the bread and circuses the people loved. Construction kicked off between 70 and 72 AD, paid for with treasures taken during the sack of Jerusalem. This wasn't just another building project. It was a statement. But building on unstable, marshy ground was going to take an engineering miracle, the engineering toolkit solution, a revolutionary material before a single stone could be laid. The Romans had to deal with a swampy valley. Their solution was to dig a huge network of drains and sewers to channel water away from the site, some of which connected to the city's main sewer system that emptied into the Tiber River. With the ground finally stabilized, they laid a foundation 12 meters deep, but not with regular stone. They used their secret weapon, Roman concrete. This wasn't the concrete we use today. The Romans had perfected a recipe called opus cementissime, a mix of lime, water, and a special volcanic ash called pozzolana. This created a hydraulic concrete, which meant it could set and harden even underwater. The Roman writer Pliny the Elder was amazed by it, saying that when it met seawater, it became a single stone mass, impregnable to the waves and every day stronger. This incredible material was the key to the Colosseum's survival. For the massive foundations, engineers used a heavy mix of concrete and stone rubble. But for the upper levels, they got creative, mixing in lighter materials like pumice. This reduced the overall weight, letting the structure soar to its incredible height without collapsing. Roman concrete could be poured into molds to form the great arches and vaults, making it both strong and versatile, the first secret to building the impossible. It's mind-blowing that modern engineers are still studying this ancient recipe for its unique properties, like self-healing. If you're finding this as fascinating as I am, make sure you're subscribed so you don't miss what's next. The Engineering Toolkit Solution. B. Clever tools with a solid foundation and a miracle material. The Romans faced their next big challenge, going vertical. The outer wall alone required an estimated 100,000 cubic meters of travertine limestone, a heavy stone quarried 20 miles away. Some of these blocks weighed several tons and had to be lifted to the full height of the structure, nearly 50 meters, about 160 feet. So how did they lift them without a single engine? The answer was brainpower, not horsepower. The Romans were masters of simple machines, and they used enormous wooden cranes to do the heavy lifting. The star of the show was the pulleys or treadwheel crane. Picture a giant hamster wheel, big enough for several men to walk inside. As they walked, their combined weight turned the wheel, which wound a rope through a system of pulleys. This block and tackle pulley system was the real genius here. By using multiple pulleys, the Romans could massively multiply the force of the workers, allowing a small team to slowly but surely hoist colossal blocks of stone into the air. It was slow, dangerous work. A snapped rope could be catastrophic, but it was brutally effective. The whole structure was wrapped in a forest of scaffolding, giving masons access to every level as the monument climbed, block by painstaking block. Section 4. The Engineering Toolkit Solution. C. The genius of the arch lifting the stones was only half the problem. The final piece of the engineering puzzle was in the design itself. How do you build something this huge that can support its own immense weight, plus tens of thousands of cheering fans? The answer is everywhere you look on the Colosseum. The arch. The Romans didn't invent the arch, but they perfected it on a scale no one had ever seen. An arch is an architectural wonder because it redirects weight. Instead of pushing straight down, the force is channeled out and down along the curve into the supporting piers. The Colosseum is basically a masterclass in the arch, with 80 on the ground floor, 80 on the second, and 80 on the third. This repetition created a framework that was incredibly strong but also relatively light. The arches and the concrete vaults they supported distributed the weight of the stone and the crowds, creating a structure with amazing integrity. But the design wasn't just for strength, it was for flow. Those 80 ground floor arches were the entrances. Each spectator had what was likely a taqueta, piece of pottery with a gate number carved into it that directed them to the right entrance. From there, they entered a series of corridors and stairways the Romans called vomitoria. The name doesn't mean what you think. It comes from the Latin verb for to spew. Fourth, because the system was so efficient, it's believed the entire stadium could be cleared with surprising speed. The finishing touches of genius completed in about 10 years. The Colosseum was a marvel. But the Romans weren't done showing off their ingenuity. Two final features cemented its legendary status. The first was the velarium, a massive retractable awning that shaded spectators from the brutal Roman sun. Modern estimates suggest this colossal canvas covering weighed over 24 tons. It was anchored to 240 wooden masts around the top of the Colosseum and operated by a complex system of ropes and pulleys. To handle it, they brought in the experts, a specially trained detachment of sailors from the Roman Navy. With some sources estimating around 1,000 men were needed. The second marvel was hidden beneath the arena floor, the hypogeum. Ancient accounts suggest that in the very first games, the arena may have been flooded for spectacular mock naval battles. While scholars still debate exactly how this was done, the leading theory is that these battles took place before Emperor Domitian ordered the construction of the hypogeum, which made future flooding impossible. This was an elaborate two-story underground network of tunnels and cells where gladiators and wild animals waited. It was fitted with sophisticated elevators and trapdoors run by pulleys and counterweights. On cue, a lion, a bear, or a gladiator could be lifted from the darkness and appear as if from nowhere, adding a shocking twist to the show. So, how did Rome build the Colosseum without modern machines? They did it with a potent combination of revolutionary materials, clever tools, and architectural genius. They used a unique concrete that could set underwater and get stronger over time. They harnessed human power with ingenious wooden cranes that could lift tons of stone. And they mastered the arch to create a structure of incredible size and strength that could manage huge crowds with unmatched efficiency. The Colosseum still stands today, damaged by earthquakes and time, but it remains one of the greatest feats of Roman engineering. It's more than a ruin. It's a powerful reminder that with creativity, resourcefulness, to deep understanding of basic principles, it's possible to build wonders. It proves that the most powerful tool ever invented, then and now, has always been the human mind. Then and now, has always been the human mind.
Front-leg sit alone. As the centuries pass, the Colosseum still watches over Rome. Not just as a monument of stone,